Hello. We are coming once again. Tuje gusobanura a simple topic called linear function. Iyo twiga twe abarimu dukunda guhura n'ibibazo abanyeshuri batubaza nk'iyo ugiye kwigisha linear function ati se ubundi linear function izamarira iki, nzayikoresha hehe? Nkuko twabasezeranije rero tuzatubigisha imibare ariko tunabafashe guhuza iyo mibare turi kwiga n'ubuzima busanzwe. Objective of this lesson is to give the rationale of linear function. Where can we apply and how can we apply the linear function in our daily life? What is linear function? A linear function, it is any connection between variables where the changes are constant. One variable change in the same way, the same rate, according to the change of the second variable. Now, simply, a linear function will be represented by equation y equals to mx plus c. We are going to understand what this m stands for, what this x, what this y, what is this c stand for, does it mean? Let's take an example. In our life, we need to save. We are going to talk about the save and we see if it can be represented by a linear function. Savings. Kugira ngo tugire ikintu tugeraho mu buzima nuko tugira savings twakoze. Now, hano dufitemo variables ebyiri. Hari amafaranga twabasha gusavinga. Amount, how much can you save? Let's take in time. This x can stand for an interval of time. Let's take that it's monthly. Monthly save. Y, in this case, y will be the amount that you are able to save. This is amount saved. What this m stand for and what this c stand for. Let's say that monthly you are earning a certain amount. Then with our daily expenses, you are able to save, for example, 100. This money, let's take this is Rwandan francs. 100 is a money that you remain with after doing everything you want. Normally savings is what you are aiming to save, not what is remaining. That is a good economist. Save before reducing other things. But let's not go deep. We are saying that we found that we are able to save 100 monthly. This m, as we studied the last one lesson, we talked about gradient. This m stands for gradient. This is m. In these two variables of ours, what this gradient is telling us? We have time, monthly, and amount of money that we saved. These are two variables. Time monthly, because where we are evaluating our savings, and then we have the amount of money we saved. Now, gradient, as you remember, it is the changes of y in terms of x. In our example, how much money can we save per a unit of time? Here, a unit of time is 100. So that's this is M stand for the money that you can save per a unit of time. Our time here is monthly. Then we are able to save 100. So that my equation will be written, y will be the amount that I will save during any time, a certain period. This is now a gradient is 100. 100, then times x. Why 100? It is 100 because it's the money that I'm able to save per a unit of time. And here, unit of time is 1 month. Then, what C stand for? C, it is before starting saving, what did you have? Wari ufite iki mbere yuko utangira gusevinga? Ushobora kuba watangiye gutekereza gusevinga, utekereza ko usevinga amafaranga avuye kuri salary, ku mafaranga uzajya uhembwa buri kwezi niba ufite akazi kaguhemba buri kwezi. Niba watangiriye kuri 0, C, it is 0. This is a constant before that you are starting to evaluate our variable y, which is amount saved amount. Now, let's say that now our savings, we are starting, before starting the job, maybe someone gave us a certain amount to settle. For example, someone gave you 50,000 before earning your salary. Before that the month end, someone gave you 50,000 to start with. This is the money that they gave you before that the income starts, you start to get the income. Now, remember, our variable here is not representing the income, but is representing the money that we are able to save monthly. This is our linear equation, where C is the money that you are having before starting savings. This is 100 represent a unit of money you can save, amount of money that you can save per a unit of a certain period. Here we are using monthly. Now, what this linear function will help us? You see, you can predict the time according to your ambition or your goals, your target. You can say that I want to have 5 millions, then after having 5 millions, maybe I will buy a car. That is your target, your goal. This now, you can say, with this linear function, how long will it take to have that 5 million? That it means, if you are asking how long, so that you are going to calculate the x, because x is the one which stands for the time. How long to do what? To have 5 million. It's that, remember, amount saved, it is y, which means you replace this y by 5 million, and you calculate how many months it will need to get what? The target of having a savings of 5 million. When you do simple calculations here, this will collect like terms, so that the number will become first side, you will subtract, and when you take 5 million minus 50,000, it will be 4,900,000 950, I think, if I did well mental calculations. This is 4,950,000 because I subtracted this 50,000, which will be equal to 100 what? 100 x. Then x will be, simply we'll divide this amount here, because so that's 100x is equal to 4 million. How about a single x? That I will divide this amount by 100 what? 100,000. That will be, when you remove this 100, they have 5 zeros. When you remove the 4 zeros on this number, another 0 will come here. You will get 49.5. That it will take you 45. Remember, unit is in months. It will take you 49.5 months to get a target of having a savings of 5 millions. You see, with a linear function, we are able to predict the time needed to get the 5 million for achieving our goal. You see, in our life now, linear function is very, very important. Again, you can now say, in maybe 5 years, my saving account will be having how much money. This is taking other variables constant. We are saying that we are saving somewhere, you're not collecting you are not earning the interest, because if you created now account where they put some interest, the savings will be adding. Now we are taking it as constant. I'm just putting 1,000 aside at each month. I put 1,000 aside. Another month I put 1,000 without maintaining other factors constant. Now I want to know, after 5 years, how much money I will have. You see, I can still maintain my formula and I use it to get how much money I will have. Our linear function is 100 x plus 50,000. Remember, 50,000 is the money that we started with before savings, that we had. With now 100, this is a unit, money that we are able to save each month. We are able to save 100. Now, I want to know, after 5 years, how much money I will have. On my what? Account. Now, what does this mean? 5 years, it is a time. And remember, my linear function has two variables: amount of money and the time. If it's about time, I will replace this x. That x is equal to 5 years. What to consider? It is the unit. Unit time, remember, I'm saving per year. Per month. The unit now, periods of savings, is a month. Reason why I have to convert these 5 years into month, with that a year is 12 months. Then my 5 years is related to 60 what? 60 months. With now this period, I can know how much money I will have after 5 years by replacing in my function. You see, it is 100 times x is now 60 month. Then I add the other constant money or constant amounts I started with. This one should be now 60. I add 5 zeros, yes. It becomes now 6 million plus 50,000. Then to that, after 5 years, my account will be 6 million and 50,000. Please, you see, with my linear function, I can know after a certain time how much money I will have. Then I started to plan accordingly. If it is very little money, I will come and adjust the monthly savings. This is 100. Instead of saving 100, maybe I make another saving using maybe 200. Remember, this 200 stands for the amount of money that I'm able to save per a unit of time. Here, a unit of time is 1 month. X stands for a month. Then plus what? Plus the 50,000 that I am able to have before getting a salary. You see, you can now adjust your savings according to evaluation you did from the linear function that we started with, which was y equal to mx plus c. This is one example of linear functioning, which is very important to know ability of saving and how much money you get after a certain time, or how long do you need to save to get any amount that you need to buy a plot, to buy a house, to buy a car, or to solve our daily problems.